Okay, so let's begin. So we have two short videos on two small topics, and that will be the end of this course. Two very short videos, and just to show you some basics. Most of the things we have already seen, but we have not probably seen them in the right way. So we look at them once again. Okay. All right. So let's begin with the Scipy package. Okay. So all of you remember the NumPy package, right? Similarly, this is a Scipy package of Python. But what is this? This is not very different. It's a scientific computation library that uses NumPy underneath. So NumPy is a subset of Scipy. Okay, NumPy is a subset of Scipy. Scipy has some extra things in this. And we don't have to look at all of Scipy. We only have to look at some very, very basic things. Okay. So for example, the constants in Scipy are a bit more. Okay. So NumPy constants are like pi, e, and those kinds of constants, right? Numerical constants, mathematical constants that you already know. Okay. But in Scipy, there are many more constants. Okay. But how do you use them? So in NumPy, for example, if you want to use pi, you will call it as numpy.py or import numpy as np and then np.py. Whereas here, you will have to start it as from Scipy import constants. That's how you start your code. And then you say constants.py. If you're asking for pi value from Scipy and not numpy. Okay, so just constants.py. All right. So let's go directly to some more involved examples. Okay, so list of all unit-centered constants can be seen using this module. So let us just look at all the list of constants that we have. All right. So let's do this. What is the code? Print dir constants. Okay. This will show us all the constants in Scipy. Okay, these are the ones. And how do you use them? Exactly the way they are written with constants. Okay, for example, you will have pi here. Look at this. Pi is here, pi. But you will use it by typing it as constants.pi. Constants.pi, correct? Similarly, you have many other constants. Okay, for example, from chemistry, you have Avogadro's constant. I don't know if you remember from 11th, 12th standard, there was some such thing. Avogadro's constant, Boltzmann's constant from physics. Okay, then there are some other things from physics and chemistry, BTU, Julian year, Planck's constant, R as in, I think this is from thermodynamics. Then there is some Rydberg constant from, again, thermodynamics, I think. Then Stephen Boltzmann constant, again from thermodynamics. Then you have other things. You have angstrom, unit of wavelength. Then you have arc minute, arc second, arc SEC. These are related to astronomy. Then you have astronomical unit, which is a unit of distance. Okay. Then you have ATM or atmosphere, which are pressure. Then atomic mass. Then atto, AU, bar, things like that. Then the temperature things, you have degree Fahrenheit. Okay. Then you can convert temperature, but then converting from one unit to other, there is a constant involved. So what is that constant? Electron mass, and there are many others. So kilogram force, okay, metric ton. This is metric ton. Then you have light year, again measure of distance, liter, mph, miles per hour, distance nautical mile, psi, again a unit of pressure. Okay, there are many such constants here. Even I don't know all of I don't know the meaning of all of these. It's a very big list. but you have a much bigger list of constants available to you in SciPy as compared to NumPy. Whatever you find in NumPy, you will have in SciPy as well. You will have many more. Okay, so it's not super important because we are mostly only concerned with mathematical constants, most of the constants found in NumPy. But just remember that in SciPy, you have many more. For example, some of the things you might be, you should probably know some very basic things about physics and stuff. Okay, so I don't want to go get into advanced physics or anything like that, but some very basic stuff. So let's go through just this, and let me mention some of these which probably are important, in order to, you should know these things. So C you should know because it is Celsius. Then calorie you should know because calorie is energy, calorie. Okay. Then day you should know. There is a meaning of day in terms of seconds. Okay. Then degree you should know. Degree Fahrenheit you should know. Okay. Then forget charge and all these, not really important. Gram you should know. G. Foot you should know. Foot. Inches and foot, right? That is the foot distance. Okay. Then gram as GRAM you should know. Okay. Hectare, measure of area, you should know. Okay. Hour, time, hour, you should know. Inch, you should know. Kilo, you should know. Okay. Liter, you should know. Right. Metric ton, you should know. Okay. Then micro, micron, milli, minute, miles per hour, all of these you should know. Okay. Pi, anyways, you will know, you already know. Pound, you should know. Okay. PSI, you should know. Pressure, very basic terminology, PSI. Speed of light, again, very basic quantity from physics. Speed of light, you should know. Similarly, speed of sound, again, very basic quantity from physics. Speed of sound, you should know. Okay. Then anything else? Week is there, about a calendar year week, and 0 Celsius. Okay. The absolute temperature scale is in Kelvin. Okay, so when you say 0 in Celsius, what is it in Kelvin, right? That is the meaning of it. So these are the basic ones which you should know. Others you're free to try. So let me just try a few of them in order to just, let's try a few of them. So print, let us say constant start. Let me pick one from what I just mentioned. So constants from ATM. Let's practice. Okay, so atmospheric pressure, this is the value. Okay. Now we can change it here itself. So let's say print constant start. There's also the gravitational constant, which you should know, capital G. Okay. C. Okay. C. Oh, sorry. Small c is again speed of light. Okay, not Celsius. Celsius comes differently. Okay. Small c is speed of light. So, for example, this is this speed of light. It's the same value. Speed of sound is this value. Okay, 340 meters per second, roughly 340.5. Right. Let's see what it gives as D. Okay, in terms of number of seconds. Okay, let's say a degree. And then degree. Okay, what else? Light year. Let's try light year. Okay, this is the distance. I think it is in meters per. Let's try week. Week is again, I think, in seconds. Okay, so that is what it is. Right. So that's how you use constants in Scipy. So let's go back. So that's all about Scipy that I want you to know. There are many other details here, but not very important. What is important for us is that these constants are much more than what are available in NumPy. Okay. NumPy usually has only mathematical constants, but Scipy has mathematical and scientific constants. For example, physics and chemistry, these kinds of constant values that you see. All right. So you should just remember a few basic ones that we just saw. Okay. So that was about constants. Second thing was about graphs. Okay. So in Scipy, we also have graphs. So we just have to look at a few things on getting some very basic parameters about graphs using Scipy. Okay, these are not graph algorithms. Graph algorithms are much more complicated, but some very basic parameters about graphs you can get. Okay, so I'll do that in the next video. So I'll break up this video into small parts. I'll do that in the next part. Okay,